Welcome back to the deep dive. Today we're tackling a subject that, honestly, it feels a bit like a biological heist movie.
Oh, that's a good way to put it.
We're looking at a virus that literally cannot survive without an accomplice. We're talking about hepatitis D.
It is a fascinating and, frankly, a pretty terrifying virus. It's essentially a parasite of another parasite.
I've heard it called a satellite virus or even a vampire virus, which sounds a bit dramatic, but it's actually true, isn't it?
It is. Hepatitis D, or HDV, is what's called an incomplete RNA virus. It just lacks the genetic code to make its own outer envelope. So it steals one.
It steals one.
It requires the hepatitis B surface antigen to packet its genome and spread.
So it basically hijacks the coat of hepatitis B to sneak into liver cells, which means if you don't have Hep B, you're safe from Hep D. But if you have both,
If you have both, well, that's widely considered the most severe form of chronic viral hepatitis.
the most severe.
Yeah, the co-infection leads to a much faster progression to things like cirrhosis and liver failure than you'd see with Hep B alone.
So the stakes are incredibly high. And that brings us to the stack of papers for today. We're looking at a phase 2 clinical trial that's testing a whole new battle plan against this viral thief. The study is titled Clinical Efficacy of Tobevibart and Elebsiran in Hepatitis D Treatment.
And this is really cutting-edge territory.
Okay.
We're looking at data that tries to answer a classic medical question. Is hitting the virus with everything we've got better than a more targeted strike?
Or, to put it simply, is 2 better than 1?
Exactly. Is 2 better than 1?
Right. So we have 2 drugs here, Tobevibart and Elebsiran. And this trial is pitting a combination of both against just using Tobevibart by itself.
It is the combo versus solo showdown. And I have to say, looking at the data, the results are, well, they're not what you might expect.
Oh.
Yeah, there's some real curveballs here, especially regarding how we even define success when you're treating a chronic infection like this.
I do love a good data twist. But before we get to the scoreboard, let's meet the players. Tobevibart and Elebsiran. They sound like villains from a sci-fi movie. What are they actually doing inside the body?
Let's start with Tobevibart. This is a monoclonal antibody.
Okay, let's unpack that. I feel like we hear monoclonal antibody all the time these days. I sort of picture them as these microscopic, heat-seeking missiles.
That is a very, very fair analogy. They are lab-made proteins designed to lock on to a specific target with incredible precision.
And in this case, the target is?
It's that hepatitis B surface antigen we mentioned, the stolen coat that the virus wears.
Got it. So Tobevibart is trying to strip the virus of its disguise.
Exactly. It neutralizes the circulating antigen, effectively exposing the virus and, flagging it for removal by the immune system.
Okay, that makes sense. Attack the disguise. Now, the second player is Elebsiran. This one is insurine.
A small interfering RNA.
Yeah.
Yes. And if Tobevibart is the missile hitting the target that's already out there,
Yeah.
Elebsiran is more like a saboteur breaking into the factory and tearing up the blueprints.
Tearing up the blueprints. I like that.
Yes. It actually gets inside the liver cells, and it interferes with the specific RNA instructions that the virus uses to make that surface antigen in the first place.
So in theory, if you use them together, you're attacking the supply chain from both ends.
That's the idea.
You're destroying the antigen that's already out there with the antibody, and you're stopping the production of new antigen with the siRNA.
Precisely. That is the hypothesis. Both agents target the hepatitis B surface antigen, or HBsAg. The logic is that hitting it from both the production side and the clearance side should be a knockout blow.
It sounds foolproof on paper. So let's get into the setup of this trial. It's an open-label phase 2 trial.
Right. Which means everyone, patients, doctors, they all knew what treatment was being given. There wasn't a placebo group here.
No sugar pills.
No. Everyone was getting active treatment, but they were assigned to different strategies to see which one worked better.
And we have 2 main groups. Let's call them Group A and Group B. Group A is the combo squad. They got both drugs, Tobevibart and Elebsiran.
And this is where the details get really important. The combo group got their treatment every 4 weeks.
Okay, once a month. That seems pretty standard for a long-term treatment.
Now look at Group B, the monotherapy squad. They only got Tobevibart, just the antibody. But, and this is the catch, they got it every 2 weeks.
Wait, hold on. The monotherapy group is getting injected twice as often.
Correct. So we're comparing a 2-drug combo given monthly against a single drug given biweekly.
That seems like a massive variable to keep in mind. We aren't just comparing drugs. We're comparing the whole treatment schedule, the intensity.
Absolutely. It's a trade-off.
Yeah.
The researchers are essentially asking, if we add this second, very high-tech drug, the siRNA, can we get away with treating the patient less frequently? Can we buy convenience with potency?
That makes a lot of sense. Less time at the clinic is always a win for the patient. So they set this whole trial up, and they're looking for a specific finish line at week 24. They call it a combined response.
Right, and combined response is a bit of a loaded term here. It's a composite metric. To win on this endpoint, a patient had to clear two very distinct hurdles at the same time.
Okay, well, let's break down those hurdles. What's number one?
Hurdle number one is the virologic response. This is the obvious one. The level of HDV RNA, the actual genetic material of the virus, had to drop significantly.
How significantly?
Specifically, it either had to fall below the limit of detection, meaning the test just can't find it anymore, or drop by at least 2 logs.
2 logs, that's science speak for a 99% reduction, right?
Roughly, yes.
Yeah.
100-fold decrease. So hurdle 1 is simple. Kill the virus. Smash its numbers down.
Okay. And hurdle number 2?
This is where it gets a little tricky. Hurdle 2 is a biochemical response. Specifically, the normalization of the ALT level.
ALT, alanine aminotransferase. We see this on blood tests all the time.
Correct. It's an enzyme that's found inside your liver cells. When liver cells are damaged or inflamed or, dying, they leak ALT into the bloodstream.
So a high ALT is basically the liver's alarm bell.
It's the liver screaming for help, exactly. A normal ALT means the liver is calm and happy.
So to win, the main goal of this study, you can't just kill the virus. You also have to get the liver to calm down. You need a clean bloodstream A&D, a happy liver.
Precisely. You need the war to be over, and you need the peace treaty signed. And that dual requirement is where these results start to get really, really interesting.
Okay, let's get to it. The week 24 results. This is the halfway point. We have the combo group versus the monotherapy group. Who won?
Well, if you look strictly at that primary endpoint, the combined response, the winner is actually the monotherapy group.
Wait, really? The single drug beat the dynamic duo?
By a pretty significant margin. At week 24, 70% of the monotherapy participants achieved a combined response. In the combo group, only 47%.
That feels completely backwards. We just said the combo attacks from 2 angles. Why on earth would the single drug do better?
This is why we have to peel back the layers of that combined metric. Remember, you have to pass both hurdles. Virus down AND, ALT normal.
Okay, so let's look at just the virus hurdle first. How did the combo group do on just killing the bug?
The combo group was perfect. 100%.
100%. As in every single person.
Every single participant, 32 out of 32, achieved a virologic response. They absolutely annihilated the viral load.
Wow. 100% efficacy. You almost never see that in a clinical trial.
It is incredibly impressive. It shows that the mechanism of combining the antibody and the siRNA is just devastatingly effective against the virus itself.
Okay, so the combo group got a perfect score on the first test. What about the monotherapy group?
They did very well, but not perfect. They had an 82% virologic response rate, so 27 out of 33 participants.
Okay, so let me get this straight. The combo group was better at killing the virus, 100% versus 82, but they lost the overall combined response. That has to mean...
It means they failed the second hurdle, the ALT normalization.
The liver inflammation.
Exactly. When we look at the ALT numbers at week 24, the monotherapy group saw 76% of patients get to normal ALT levels. But in the combo group, it was only 47%.
That's a huge gap, 76 versus 47. So even though the combo drugs were nuking the virus, the livers in that group were staying inflamed for longer.
That is the story at week 24. The monotherapy, maybe because of the dosing, maybe because of the mechanism, it allowed the liver to quiet down faster, which led to a better combined response score on paper.
Well, why would that happen? I don't get it. If the virus is gone, 100% gone, why is the liver still angry?
It's the paradox of immune clearance. Clearing a virus is a tumultuous event for the body. When you remove a massive viral load that quickly, you're shifting the whole immune environment. Sometimes that rapid clearance is associated with continued inflammation as the immune system just cleans up all the debris.
It's like the battle is over, but the city is still on fire.
That's a great image. Exactly.
So the monotherapy might have been a gentler clearance process?
Potentially.
Well,
or simply a bit slower. Whereas the combo was a shock and awe campaign that left the liver a little bit stunned.
so if we stopped reading the study at week 24, we'd probably say, well, monotherapy is the winner because the patient's livers are happier. But the study didn't stop. We have data out to week 48, a full year.
And this is where the story shifts. This is the long game.
Right. So does the combo group catch up?
They do. When we look at that combined response at week 48, the gap narrows significantly.
Yeah.
The combo group rises to 56%, and the monotherapy group, it actually drops a little to 61%.
So they're basically neck and neck, 56 versus 61.
Statistically, they are much, much closer. The sort of tortoise and the hare dynamic starts to play out. The combo group's livers finally started to catch up and normalize.
But there's another metric here that I think is even more telling. The target not detected, or TND. This is when the PCR test looks for the virus and just finds nothing. Silence.
This is the deepest level of viral suppression you can measure. And at week 48, the combo group takes the lead here. A big lead.
How big?
66% of the combo group had undetectable HDV RNA.
Compared to?
Only 48% in the monotherapy group.
Okay, so now the tables are really turning. The combo group is showing a deeper, more profound clearance of the virus over the long term.
And that brings us to what I think is the most striking data point in the entire study. The HBsAg levels.
This is the target, right, the food source, the coat the virus wears.
Correct. Remember, the whole goal of both of these drugs is to reduce the hepatitis B surface antigen. If you get that antigen low enough, you are theoretically curing the environment that allows HDV to even exist.
You aren't just killing the mosquito, you're draining the swamp.
You are draining the swamp. So how did they compare on reducing this specific antigen?
This sounds like the big reveal.
This is the blowout. At week 48, the percentage of participants who got their HBsAg level below 10 IU per milliliter, which is a very, very low threshold.
Drum roll, please.
In the monotherapy group, only 21% reached that level.
21%, okay. And the combo group?
91%.
Whoa. 91% versus 21%.
It is a massive difference. 29 out of 32 people in the combo group saw their antigen levels just plummet to below 10.
That's night and day. That completely changes the perspective on that loss at week 24.
It forces us to look beyond that simple composite score. While the monotherapy was maybe faster at normalizing liver enzymes at first, the combination therapy is doing something fundamentally different to the infection. It is wiping out the viral infrastructure, the antigen itself, in a way that monotherapy just isn't.
It's the difference between mowing the weeds and digging up the roots. The monotherapy mowed the lawn really nicely and quickly, but the combo is digging up the entire root system.
That is a perfect analogy. The surRNA component Elebsiran, combined with the antibody, is effectively starving the infection out by taking away that surface antigen.
And if you remove the antigen, the hepatitis D virus literally has nowhere to go. It can't replicate.
It's stranded. It suggests that the combo therapy might offer much, much better long-term outcomes, potentially making it harder for the virus to ever bounce back.
Okay, but we have to talk about the cost. And I'm not talking about the price tag. I mean the physical cost to the patient.
Right. These are potent drugs, and the data shows they are not a walk in the park.
What are we looking at for adverse events?
High numbers. Through week 48, 81% of participants in the combo group reported at least one adverse event.
That's the vast majority of them. What about the monotherapy group?
Even higher, actually, 94%.
94. So basically every single person on the monotherapy felt something.
Almost everyone. And when we look at the specific symptoms, it paints a very clear picture. The primary complaints were influenza-like illness and chills.
So flu symptoms, feeling achy, feverish, shivering, that kind of thing.
Exactly. And it makes sense, given the mechanism of action. We are stimulating the immune system. We are injecting antibodies. The body thinks it is fighting a flu because the drugs are simulating that kind of immune engagement.
It's interesting that the monotherapy group had a higher rate of side effects, 94 versus 81. Do we know why?
The source doesn't speculate too deeply, but remember the dosing schedule we talked about at the very beginning.
Ah, right. The monotherapy group got injections every 2 months. The combo group was every 4 weeks.
Exactly. More injections might just mean more opportunities to feel crummy for a few days. If every shot triggers a mild flu-like response, the group getting twice as many shots is naturally going to report more events.
That is a huge quality of life issue. Even if the monotherapy calmed the liver down faster, getting flu symptoms every 2 weeks for a year, that is a tough sell.
The treatment burden is a very real factor in whether patients can stick with it. If you feel terrible half the time, that's a problem.
Now, there is one piece of good news in the safety data, something about ALT flares.
Yes, this is critical. In hepatitis treatment, sometimes when you start messing with the virus, the liver can just freak out. You get a massive spike in ALT flare.
This isn't just inflammation.
No, this can be acute liver injury. It can be very dangerous.
And in this study,
No ALT flares were observed. Not in the combo group, not in the monotherapy group.
that seems huge. So even though their ALT levels didn't normalize immediately in the combo group, they didn't have these dangerous spikes either.
Correct. It suggests the treatment is manageable. The liver is stressed, yes, but it isn't crashing. It's not causing acute liver failure while it's clearing the virus.
So let's try to put all this together. It's a really complex picture.
It is. We have two strategies. Monotherapy, Tobevibart every 2 weeks, combination. Tobevibart plus Elebsiran every 4 weeks.
If you look at the so what for a patient or a doctor, how do you weigh these?
Well, the data tells two different stories depending on your timeline. If you're looking for a quick normalization of liver enzymes, getting that ALT down, the monotherapy actually looked better early on. It had that 76% normalization rate at week 24. But if you're looking at the virological drivers, the actual root cause of the disease, the combination therapy is superior. It hit 100% virologic response at week 24. It had higher rates of undetectable virus at week 48. And most importantly, it decimated the HBsAg levels, 91% versus 21.
That 91% number just sticks in my head. It feels like the combo is the more curative approach, even if the liver takes a little longer to get the memo.
That is a strong interpretation and I think a fair one. The deep suppression of that antigen suggests the combo therapy is removing the very foundation the virus is built on. Plus, there's the lifestyle factor.
Dosing every 4 months versus every 2.
Right. Less frequent visits. Potentially fewer days feeling like you have the flu. So while that combined response endpoint at week 24 favored monotherapy, the totality of the data, the antigen clearance, the dosing schedule, it really points toward the huge potential of the combination therapy.
So the verdict from this phase 2 trial seems to be adding Elebsiran to Tobevibart works. It drives down the antigen and clears the virus to undetectable levels much more effectively than Tobevibart alone.
But it requires patience when it comes to the liver enzymes. You have to accept that the combined response might lag behind the viral clearance. You have to trust that if you remove the virus, the liver will eventually heal.
A classic case of the biology being more complicated than a single checkbox.
It always is, and we should absolutely remember this is phase 2 data.
The standard disclaimer.
Yes, promising but ongoing. We need larger phase 3 trials to confirm these findings. We need to see if that massive antigen reduction translates into long-term off-treatment cures.
But for now, it's a fascinating glimpse into the future of treating hepatitis D. It feels like we're moving from just managing the disease to actually attacking its structural integrity.
It really does. It highlights how targeting the machinery of the virus, the RNA and the antigen, can produce these really dramatic results.
So here's a thought to leave you with. We saw that the combo therapy knocked out the surface antigen, the virus's food source, at a rate of 91%. The enemy was, for all intents and purposes, gone. But the liver enzymes, the ALT, only normalized in 56% of those people by the end of the year.
It is the lingering question of the study, for sure.
Why the disconnect? If the bad guy, the antigen, is gone, why is the liver still acting so stressed? Is the liver is it slow to heal? Or is there something about the immune system's cleanup process that keeps that inflammation going long after the threat is neutralized?
It challenges us to understand that virus-free doesn't immediately mean healed. The body has its own timeline, and sometimes the recovery phase on a blood test can look a lot like the battle phase.
Something to mull over. The body is a mystery even when we have the blueprints. Thanks for joining us on this deep dive.
A pleasure, as always.
We'll catch you on the next one. Stay curious.